So in this example, we are asked to find the double derivative of the function z with respect to x and y, where z is equal to x to the fourth divided by y squared. So the formula that we will need to know is that the double derivative of y, I wrote that wrong, the double derivative of y with respect to x is equal to the derivative with respect to x of the derivative of y with respect to x. So it's pretty easy to apply that. So first we'll write out the double derivative of function z with respect to x squared. That's going to be equal to the derivative with respect to x times the derivative of z with respect to x. That's going to be equal to the derivative with respect to x of the derivative with respect to x of x to the fourth, and we'll write out our constant in blue. So y squared would be the constant that we can pull out. So pulling that out, we will have the derivative with respect to x times the derivative with respect to x of x to the fourth. Now, just using the basic power rule, we get that this is equal to 4x to the third. And again, we can move this outside of the derivative and just take the derivative of this equation right here, and that will yield us 1 over y squared times 12x squared. And so writing this out fully, we will have that the double derivative of z with respect to x is equal to 12x squared over y squared. For the next part of this, we are asked to find the double derivative of function z with respect to y. So that is going to equal the derivative with respect to y times the derivative with respect to y of the function z, which is x to the fourth over y squared. And so we can write x to the fourth as a constant, so we'll represent that in blue. We can move this outside of the equation, and 1 over y squared is equal to y to the negative 2. So we can write this as x to the fourth times the derivative with respect to y times the derivative with respect to y of y to the negative 2. Now, this is fairly simple to take the derivative of. We just use the power rule. So we have x to the fourth times the derivative with respect to y times negative 2y negative 3. I'll actually write this as negative 2 minus 1, which is equal to negative 3. Simplifying this further, we get that this equals x to the fourth times negative 2 times negative 3 y to the negative 4. So we can simplify this and say that the double derivative with respect of function z with respect to y is equal to x to the fourth divided by y to the fourth times 6.